All right, we're on the second part for the page 2. Instead of doing the 7 first, I'm going to do the 8 first, just to show you how you can mark it. So if I start here and I go 1, 2, 3, 4, and I go up diagonally, so I'm going to go up 2, almost kind of like a straight up. So if you see this, I'm going to go 1, 2, 1, 2, 3, 4. So this line is kind of straight up. 1, 2, 3, 4. And I just connect it like this. You can see the sides of those 8 cubes. Now to make it look three-dimensional, I'm just going to go from this bottom corner, diagonal, back up to the left, back up to the left, back up to the left. And these that I shaded in are kind of the front. And then I'm just going to do this diagonal, but I'm not going to go past this line. I'm going to go one line over. So there you can see all 8 cubes. Now we're going to do that same thing, except we're not going to draw this front cube right here. So again, we're going to draw 1, 2, 3, 4. We're going to go straight up, 1, 2. So this is a straight up line. We're going to go 1, 2, 3, 4. On this one, we're only going to go 3. 1, 2, 3. Because right there are 2 cubes. 1, 2, 1, 2, 1, 2. And then this one, so now it looks kind of like just the side of 7 cubes. Now we're going to go across and across. That will be those 2 cubes. And we're also going to go from this cube straight across like so. And that leaves this cube, you can see this whole cube right there. Now for this one, we're going to go diagonal this way. 1, 1, 2, 3. And that gives you the top of these cubes. And so you can see right here, it almost looks like a bus or something, or a truck. And you shade it down, then you can see that you have 7 cubes there. And then this one, Joyce says that the figure below is made of 1 centimeter cubes. It has a volume of 5 cubic centimeters. So I see 1 cube here, which is this whole cube. Even though it has 3 faces, you can see it's just 1 cube. So that's 1 cube, 2 cubes, 3 cubes, 4 cubes, 5 cubes. But how is this cube staying up? That cube can't stay up because there's one hidden under it. So she did not count correctly because Joyce is not counting the cube hidden under the highest cube. Because if there was no cube under this one, then this one would be the same height as the orange one. So there has to be a cube under that one. And then B, imagine if Joyce adds a cube, a second layer, so the cubes completely cover the first layer in the figure above. What would this volume be? So if you added a cube that completely covered the first layer, Peanut, come here, come here. Sorry, my dog's seeing a bunny outside. If you were just going to cover this cube, this cube, this cube, and this cube, there would be 4 more cubes to add to this 6 cubes. So if you already have 6 cubes, 1, 2, 3, 4, 5, and the one hidden underneath, you have 6 cubes, and you're going to add 1, 2, 3, 4. That would equal 10 cubes. Some of you might read this where you're adding 1, 2, 3, 4, and then a 5th cube up here, which means you have 6 cubes and you're adding 1, 2, 3, 4, and then a 5th cube on top of this one. So it would kind of look something like you have 2 layers here. So then it's like the bottom layer, the second layer that looks the same, and then that cube there. So that would be 6 plus 1, 2, 3, 4, 5 plus 5, which means that you would have 11 cubes. So depending on how you read this question, some of you will come up with the answer of 10 cubes because you're just adding 1 on top of each of these 4. Some of you will say 11 cubes because you're adding 1 on top of these 4 and then 1 on top of this one. We can accept either of those answers as long as you understand how you're getting to it and as long as you explain that you're adding cubes on top of just the first layer or you're adding cubes on top of each cube that's already there. I believe the answer key has it as 10. When the class worked it out, some of the classes will have it as 11 cubes. Again, we're just getting you to understand that if you place cubes on top, that makes the volume larger. Thank you so much. I'll see you guys tomorrow.